Hey guys, welcome back to Swats Tools. Today we are going to see the basic shader development of the HulkBuster. I'll be explaining how we are going to differentiate three different material properties of red, yellow and cyan parts using vertex color masks and layered texture in a single shader. So let's start. Before we start, I want to clear a few points with you guys. My intention is not to create the exact replica of the shader or the render of the HulkBuster which I have already created. What I want to show you is the methods by which I have created that output. So it won't be like me creating a bunch of nodes and adding some fixed values to the attributes and finish off. I'll be explaining each process step by step and most importantly why I follow those methods. So with this tutorial session, what I want you guys to learn is not how to create a HulkBuster shader, but how you can create any photorealistic materials and textures with procedural or texture maps. So let's get started. So we are starting from where we left off by creating the final output of the vertex color sets. And now we are going to start our base shader development. First thing we have to do is add the Cat-Clark subdivision to the HulkBuster. So whenever you get an asset, you shouldn't smooth the mesh on 3D viewport. What the process we follow these days are we add open subdivision on the mesh, which will be calculated on the render time so that the mesh won't get heavy on the viewport by smoothing. It will only smooth the mesh when it is rendering. So in Arnold, we do it by adding a subdivision type called Cat-Clark. Let me show you where this option is in the geometry. So if you come to the shape node of the any particular geometry, if you open the Arnold folder, if you come down, there is a subdivision subfolder here. By default, it will be on none, which means no smoothing or no subdividing the mesh. So you have to make it to Cat-Clark, and according to your need, you will change the number of iterations. So if you are using any displacement maps, you will have to subdivide the mesh to 3 or 4, depending on the mesh poly count already there when you are modeling the mesh. So here we are not going to use any displacement maps, so we'll be leaving the iterations on 1. So for doing the whole mesh to Cat-Clark subdivision, what we can do easily is click and drag all the mesh and go to Windows, General Editors, Attribute Spreadsheet. In there, go to the Arnold tab and type here subdivision. So here you can see AI subdiv type and AI subdiv iterations. So by default, it will be on 0, which is none. You can click on the title, which will select all the attribute of the all geometry here, and you can press 1 and click enter. So it will change the whole geometry subdivision type to Cat-Clark together. Then you can press on the subdivision iteration title, then you can add any number you want here. So it will change the whole geometry's subdivision iteration to 1. So let's see it on the render view with the wireframe debug shading so that you'll know what is the difference which is happening. So if I change the subdivision iteration to 0, you can see the mesh count is exactly equal to the mesh count which is visible on the viewport. So if I change the number to 1, it will smooth the mesh or it will subdivide the mesh by 1. It is exactly like doing a smooth attribute on the geometry, but the only difference is we are doing it in the render. So if I add more and more subdivision, you can see the mesh gets really smooth, which will come in handy if we are adding any displacement maps. So we are not adding any, so we are leaving it as in 1 value. So that's the first thing. If you get any object on Lookdevelopment, that's the first thing you should do. And the second thing is adding the lights or the Lookdev rig, which we are going to use for the Lookdevelopment. So I have already added this Lookdev rig here. You may have already seen this Lookdev rig. This is the exact Lookdev rig which I have created in my tutorial, Lookdev rig with area lights. I have put the link in the description if you want to use the same Lookdev rig for you. If you want to use any HDRI also, that will work fine. But make sure you follow the rules which I have already showed you on other tutorials like Lookdev rig creation with HDRI and Lookdev rig creation with area lights. So if you want to create one on your own, you can check the tutorials for that it will help you, or you can just download this one and use it. So let's start creating the shader for the HulkBuster. So let me just select all the HulkBuster and create a new material for this HulkBuster. I'm using AI standard surface for this one. Now let's just rename this shader to HulkBuster base, and I usually put MTL, means material, on the end so that it will be easy for me to understand that this is a shader. And I use the same name in the shading group also with the end tag SG, which means shading group. So we have assigned our shader. So let's first create the base colors. If there is any displacement, I usually first create the displacement map so that I'll know the final mesh output, how it's going to look, and then only I'll start the creation of base color. So here we are not using any displacement, so we are going straight into creating base color or diffuse color. For the diffuse map, we are not just creating flat colors for this. We will be creating some procedural maps to break the textures so that we get some more realism on the textures. So for that purpose, we'll be using more layers of textures for creating those breakups. And usually on any procedural texturing, we'll be using more and more layers to create more and more variations or breakups to, bring the naturality or realism on shaders. So for that, I always use layered textures. If you have never used layered textures before, if you have any experience with Photoshop, you'll understand it better, because this is the same principle of layers which is used in Photoshop we are applying here. There will be a stack of layers on the layer node. Let's create a layer texture here. For base color, I create aiLayerRGBA. So there are two types of layer texture here, aiLayerRGBA and aiLayerFloat. The difference between aiLayerRGBA and float is that one is mainly for vector channels, which have 3 channels, and layer float is for scalar maps on which the input has only one single channel. So that's the main difference. And also the attribute difference is that the aiLayerRGBA has operations same as the blend modes in Photoshop, whereas aiLayerFloat doesn't have that one. We can use aiLayerFloat for scalar attributes like roughness map, bump map, or any diffuse strength if you're using any strength map for diffuse or specular. But mostly I prefer aiLayerRGBA for all the attributes, because I can use this operation on all the other maps, because sometimes we'll need this operation mode on even roughness and bump maps. It depends on the object and what kind of output we are trying to create. But I prefer this method using aiLayerRGBA. If you come to see this aiLayerRGBA, we have a bunch of layers like layer 1, layer 2 up to layer 8. And layer 1 is the bottom layer of the stack, and layer 2 comes top of the layer 1. When we add any color here, the information on AI layer will be only the single color which is on the layer 1. So if you enable the layer 2, then we'll be having the information of the layer 2 also on the aiLayerRGBA. So to see both the layer 1 and layer info, we merge this one maybe with operations, or also we can merge these 2 layers with mix. So mix is like layer mask in Photoshop. If I put the layer mix value to 0, then none of this information on the layer 2 will be visible. Only the layer 1 information will be visible on the object. If I put it to 1, then the whole information will be from layer 2. None of the layer 1 information will be visible. So if we want to completely override the layer 1 information with layer 2, then we put the operation mode to override and put the mix value to 1. This is the basic settings we change on the layers. So if we want to add any textures or inputs, we put it into input. Then if we want to blend it with any operation, we do that with operation. Or else if we are trying to blend this or mix this one with any particular mask, then we add the mask into the mix, and the mix will read the black and white values or gray values from the map, and according to that information, it will show the layer 2 and layer 1. So if we are connecting a black and white map into layer 2 mix, then wherever there is white part, it will show the information of layer 2 on that part, and wherever there is black parts on the mix, it will show the information which is on the bottom layer of that particular layer, which is layer 1. And if it is on in between values, which will be on the gray values, then it will blend the layer 1 and layer 2 information. So enough talk, let me show you that thing on the shader. So I'm connecting the aiLayerRGBA to the base color of the HulkBuster shader, and I am renaming the layer to aiLayer Diffuse Layer RGB. So it is a good practice to rename all the nodes which we create. Once we continue making all the nodes and developing the shaders, there will be a lot of nodes and we'll never get confused if we rename all the nodes properly, so that the workflow will be easier. So when we got into some final times and we want to go back and adjust some settings, but we don't know which node has that particular info or particular attribute which we need to change, then there will be a lot of confusion. But if we have renamed all the nodes properly, then it will be easier for us to find that particular node and change that particular attribute very fast. So make it a habit to rename all the layers at the same time when we are creating it. So I have added the layer 1 as red, and let me just disable the layer 2 for now and just render this one. So you can see the whole Arnold diffuse color is coming into red. So before rendering, let me just show you the basic render settings I am using. So for the starting, I have added camera samples as 4 and diffuse and specular to 1. This is my starting point, and this will change according to the shading detail, and if it is more reflective or if it is more refractive, if it has triple S, according to which material properties we are adding on to that particular shader, we will have to add some samples, and we'll have to increase samples according to how the shader is coming, how much noise is there on that particular shader. So for the starting point, I'm just leaving it on 411. We don't have any refractive or glass parts on HulkBuster, nor any subsurface scattering parts. So I'm putting all those values into 0, and ray depth I'm putting on default 1 and 1. So these are the sample settings, basic, and rest of all the things I'm leaving it in default settings. And on the AOVs, I'm using normal for seeing the bump details, and then the basic AOVs I'm using here is diffuse albedo to see the textures, because we are creating textures procedurally, so we'll need to see the albedo map, which is the exact texture we are adding into that diffuse color, to see how it is coming, the colors and all. And then diffuse direct, diffuse indirect, specular direct, and specular indirect. So this is the basic render settings which I am using for this particular object. So we'll be adding more and more AOVs if we need any extra AOVs after. So here we are going to the reference. So from here we're gonna start looking at the reference for the colors. So we're gonna first set the base layer into the red color, because the red color has the most percentage in the HulkBuster. So I'm just adjusting it a little bit to get the, try to match this color. So I'm not going to be exactly matching the color into this particular color, but still we are trying our best to get close enough. So I guess this is somewhat close, but we'll be adjusting the colors all once we finalize the overall shader, because we are only adding single colors into single layers. It will be easier for us to come back even on the final stages to just adjust some hues or saturation after. So we don't have to worry about creating the accurate colors from the starting itself. So let me just add the second layer here. So because it is on operation override, it is adding the particular color which is black on the given percentage, which is around 70% into that layer 1. So if I put it into 100, you can see the color which I have added is completely overwriting the layer 1. See, so if I add a yellow color here, it is overwriting the whole red. And if I put it in the middle, which is 50%, like 0.5, then you can see it is blending the red with the yellow. So on the lower levels, it is giving some kind of orangish color. So this is what mix do. It will mix the two colors according to this mix value. So if I want to add any mask here and control the two colors with the mask, then what operation I'll be using is override. So that is what we are going to use here, because we have separate vertex color mask we have created to separate these two colors. So now we will be using the vertex colors masks here to see how we can separate these two colors on the diffuse. So let me just create an aiUserdataColor, and I'm just renaming this one to RGB mask. So renaming it into something else also doesn't matter, because this is just name for us to understand which node is this and which mask is this. So I can add user data RGB mask. So I'll understand this is a user data node and it is RGB mask. So let me just add the RGB mask name, which is the vertex color name here. And let me just view this on the shader. So to just view this node on the shader, you can connect it into any of this attribute, which will not affect the final shader. So we are not using any emission here. So I can connect this to emission, or else I can add it into any AOVs so that it will get connected here, and I can click this isolate button and it will show whichever data in the aiUserdata on the objects which are assigned to this HulkBuster base material. Now what I want to do is I want to control this layer to a yellow color only to be visible on the yellow parts of the HulkBuster. So for that, first we have to know which color is we have painted for the yellow parts. So it is red, and if I come to the red channel, you can see on the red channel only the yellow parts are on white and all the other parts are on black. So this is like a layer mask, or the mask which we can use to differentiate these two layers. So what I'm going to do is I'm going to open its attributes by clicking these three lines here. So in here we can see the out color is having the data of the vertex colors, and if I open this plus button, you can see there are channels data here, like red channel, green channel and blue channel. So what I want here is the red channel data, and I'll be connecting the red channel data into the layer RGB's mix 2. So if you can't find this on the node itself, you can click on the circle to create a connection and go to this top left side bubble or circle, and you can select other. So here we'll get all the node attributes together here, so we can select whichever attribute we want to connect it to. So we want to connect it into mix 2, and you can see here like some of them are disabled on here. It is because what we are connecting here is only a single channel, and all the disabled inputs are vector channels which have 3 channels. If you select this plus button and click it here, you can see all the single channels which is coming under this particular input. So that's why it is getting disabled here. We can't connect a single channel into vector channels like 3 channel inputs. So we'll click on mix 2, and you can see the red channel is now connected into the mix 2, and the output has changed to red parts only visible on the red and yellow parts are only visible in the yellow. So this is how we create shader separation with vertex colors. So the same thing we'll be using on metalness and roughness also, but let's continue with the color adjustment now. As we have said on the planning, like if we have seen the HulkBuster movie, this is not exactly an orangish yellow on the movie. It is more like a greenish yellow kind of. You can see here too, it is kind of like a greenish yellow. So and we'll try to make it a little bit yellow here, and let's just move to the next layer here, because we'll be adjusting it once we add the metalness and all the other attributes, because this yellow color will be changing after we add metalness to that particular part. So the next we'll be adding the white metallic parts. So for that, let's check again which channel it is coming, which is coming on the green channel. So I'll be picking the green channel dot here by clicking it and dragging, and I'll be releasing it on the left top and selecting the other. So now I'll be connecting this into, so we have used layer 1 and layer 2 now. So we'll be next using layer 3. So I'm adding it into mix 3. Now we can enable this mix 3 and change the operation into override. So now you can see the color is coming on the metal parts. So you can add some value. We don't need any colors in this one. We just need a value. So I'll just add 0.45 in here. So we have created the basic colors for this HulkBuster. So this is our base color setup. Now what we can do is we can create metalness maps for these 3 parts. So for that, I'm using aiLayerRGBA float, and I'm going to connect this out value into the metalness. So in here you can see, if you click it here, you can get all the attributes of that particular shader on the node editor. So I'm connecting the out value into the metalness. So I'm adding a value of 1, which creates the whole mesh metallic. That's not what we want. So in here we created the red as a base layer, right? So here also we are treating the base layer for the red. So I'm adding the layer 1 into red. So let's rename this one also. This is red, this is yellow, and this is iron. Let's just rename it as iron for now. And this is our metalness. Okay, so a second layer will be for yellow, and second layer will be completely metallic. So it will be 1. So the slider by default goes to 10, but if you see the metalness here, it will only go till 1. So make sure that you don't put any value which is higher than 1, because it will break the physicality of that particular shader. So let me just add the metalness again, and let me just put it into 0 and yellow to 1, and then again enable 3, which is our iron, and that is also will be metallic. So I'll put that also into 1. So I'm adding the red channel into mix 2 and the green channel into mix 3. Okay, the shader wasn't updating. Okay, now we can see our red part is painted metallic, which is dielectric, and all the other parts are now acting like a metallic shader. So if I come to the diffuse albedo, only the red is in the diffuse albedo, because all the others are now metallic reflection, which will be visible on the specular albedo. So if I add the specular albedo AOV here, you can see the colors which we added as diffuse for the yellow and iron parts. Now when we added metallic onto those parts, it has changed to specular albedo, because the colors of yellow and white are now became metallic color, which will be visible only in the specular albedo. It has no diffuse information. So if we put the values here into like 0.5 or something, now this is half diffuse, which has some diffuse information, and half specular. So usually there is no element which is half dielectric and half metallic. It will have some parts which is rusty or something, and it will act as a dielectric, and the rest of the parts will be pure metallic. So it's a best practice to leave it as complete metallic or completely dielectric. So you can control this mix to add some patterns or shaders which will break the metalness to some amount of dielectric and metallic. We will be doing that later. Now we have created the diffuse material and also the metalness of that particular material. And now we'll add some roughness to these objects. So in our reference, the yellow parts are really rough. These are all rough. And the only object which has a bit of glossiness is the red parts, which we can see here and some areas here. And if you see the HulkBuster fight sequence, you can see the most reflective part on the HulkBuster body is the yellow metallic part, because it is gold plated metallic. It is totally reflective, and this one is also reflective but not like the metallic. Because of its metallic property, the reflections are clearly visible on the yellow part other than the red part. And this one I kind of feel the same on both of the shaders or both of the images. Like on the fight on this image also, this one has a kind of a rough specular. So we'll be creating the yellow to be more reflective than the, or more glossy than the red part here. So here also I am using aiLayer float for the roughness, and I'm going to add the base roughness to be 0.2 for the red part. You can add the out value from here by opening this attributes, or else you can click this button and you can get the out value from here and you can add it into the specular roughness. So this is our SPCR specular roughness layer. And now the second layer, which is the yellow. Let me add the red channel from vertex color to the mix 2, and I'll add a base roughness of 0.1 to this particular yellow part. And then for the iron part, I'll add a roughness of 0.35 for the start. And let me just connect that map vertex color channel to the mix 3. So let me just render this one, see how it is looking now. So you can see now our yellow parts are really reflective. Now let's just go back to the diffuse layer and adjust some saturation, because it feels really saturated right now. And okay. So again, we'll be changing this after we have added all the other layers also. This is a back and forth process actually. We'll be coming back to the shader once we feel that some layers or some colors or some attributes need some changes according to the layering, and that is totally fine. It is part of the process. So now we have some basic diffuse color, specular color and roughness. So this will be the base setup for the shader. Now we'll start adding some breakups into the color. I'm winding up the part 2 here with the basic shader development. On the next part, I'll be explaining how to add breakups to the diffuse, metallic and roughness with a fractal node using triplanar projection. I was planning to include that in this part, but the video length got longer than expected. So I'm splitting it in 2 parts. So let me know what you think about this video in the comments. Hit a thumbs up if you liked it. Subscribe to the channel for more future contents. I'll see you with the next part. Till then, take care. Bye.